Hello students, today I'll be dealing with a very important topic of physics called calorimetry, and we'll be talking about heat, temperature, heat capacity and specific heat capacity. Let's begin. So when we talk about heat, as we know, heat is a form of energy which is in transit from one body to another solely due to the difference in their temperature. When there are two bodies and the bodies are in contact, heat will flow from one body to another due to the difference in temperature. Means if there is no difference in temperature, heat won't flow, and heat will flow specifically due to the difference in the temperature. As we know that SI unit of energy is joule, so SI unit of heat energy will also remain joule, and the common unit which is used to measure heat energy specifically is calorie. Here I have defined calorie. What is 1 calorie? 1 calorie is the amount of heat energy required to raise the temperature of 1 gram of water by 1 degree Celsius or 1 Kelvin, which is preferably from 14.5 degrees Celsius to 15.5 degree Celsius. And calculatively, 1 calorie is equal to 4.186 joule, or better say 4.2 joule, and 1 kilocalorie is equal to 4186 joule, approximately also written as 4200 joule. So when we were talking about heat, I told that heat flows from one body to another solely due to the difference in their temperature. So let's try to know what temperature is. So temperature tells us the degree of hotness or coldness of a body. How hot or how cold a body is, we'll come to know by measuring its temperature. We all know that thermometer is a device which is used to measure temperature. There are basically two type of thermometers available in market. One is clinical thermometer and another is lab thermometer. Now SI unit of temperature is Kelvin, but the common used units of temperature are degree Celsius and degree Fahrenheit. Degree Celsius was earlier known as degree centigrade also. What we need to know that the change in Kelvin is equal to the change in degree Celsius, means their unit difference is same. The only difference is that Kelvin starts from 0, which is the least hypothetical temperature, minus 273 degrees Celsius is considered as 0 Kelvin, and with respect to that, as we increase 1 Kelvin, it will become minus 272 degrees Celsius, like that. And since Kelvin is never negative, it is also called absolute unit of temperature. Let's move to the next topic, heat capacity and specific heat capacity. These two are very important topics that we need to know. When we say heat or thermal capacity, we need to know that heat capacity of a substance is the amount of heat energy required to raise the temperature of that substance by 1 degree Celsius or 1 Kelvin, because we know that whether it is increasing 1 Kelvin or 1 degree Celsius, both means the same. Like just suppose there is a substance and that temperature of that substance need to raised by 1 Kelvin, then it will require some amount of heat. The temperature won't increase on its own, but it will require some heat. And how much heat it will require, it is not same in every object, like every material, better say. Just suppose if we have something made up of, just suppose a ball made up of metal and another ball made up of soil or sand, will not require the same amount of heat to get its temperature raised by 1 Kelvin. So that defines the heat capacity of that particular metal ball or that ball made up of sand or soil. So here we can see that heat capacity is equal to the heat energy required upon change in temperature. We denote it by C prime or C dash, we can say, which is equal to Q upon delta T. The SI unit of heat capacity is joule per Kelvin, can also be written as joule per degree Celsius, because here the difference in the Kelvin and difference in degree Celsius are same. Other units of heat capacities are calorie per Kelvin, calorie per degree Celsius, and kilocalorie per Kelvin and kilocalorie per degree Celsius. Now we'll come to the topic called specific heat capacity. See, this is the heat capacity of a particular material. Like when we say like heat capacity, if amount of water is different, the mass of water is different, heat capacities will be different. So that's why we talk about specific heat capacity, where we are trying to calculate the heat capacity of unit mass of water or any substance like that. Specific heat capacity of a material is the amount of heat energy required to raise the temperature of that substance by 1 degree Celsius or 1 Kelvin per unit mass. For 1 kilogram of it or for 1 gram of it, how much heat energy is required? Specific heat capacity is equal to heat energy required upon mass into change in time. We can also better say that specific heat capacity is the heat capacity per unit mass. Like if I say that a particular substance has a certain amount of heat capacity, if we divide it by its mass, we'll get its specific heat capacity, and the SI unit is going to be joule per kg per Kelvin or joule per kg per degree Celsius also can be written. Water has a considerable high specific heat capacity, which is approximately 4200 joule per kilogram per Kelvin, which we had already talked about when we were talking about the definition of calorie. So when it is 4200 joule per kg per Kelvin, that means water can act as a good, you can say, coolant. In like a few years back, when there used to be automobile engines, because it produces a lot of heat, so to maintain its temperature, water used to be used as coolant. Now there are synthetic coolants available, so water is not quite often used, but water is a good coolant because of the high specific heat capacity of water. Now, the principle of calorimetry, it is also again a very important topic, says that when two substances of different temperature are brought in contact, let's talk about two liquids, you'll understand it better when we say liquids. When there are two liquids which are brought in contact and they are mixed together having different temperature, you know that hotter body will start cooling down and the cold body will start heating up and will both acquire a common temperature. So it is said that if no energy is radiated or no energy loss is observed, according to the principle of calorimetry, heat lost by the hot body is equal to heat gained by the cold body. Now the last topic here we have is principle of method of mixture, which says principle of method of mixture says that if two bodies or two liquids, better say, of mass m1 m2 having a specific heat capacity c1 and c2 respectively, the first liquid is having a temperature T1 Kelvin and the second one is having a T2 Kelvin temperature, such that T1 is greater than T2. That means the first substance of mass M1 is, first liquid say, is hotter than the second liquid. They are mixed together and definitely stir well. Then they both will acquire a common temperature, say T. Then the heat lost by first liquid, which will be equal to M1C1 T1 minus T, will be equal to M2C2 T minus T2. Hope you would have liked the video. Thank you for today. We'll meet again. Thank you.